Hey, the topic today is integration by substitution, specifically the change of variable method, and then doing use of with definite integration, because some little things happen that we gotta be aware of when we have definite integrals and we're using use substitution. This corresponds still with section 5.5 in our textbook, but before we go further, I heard a joke I got to tell you. So, why does a golfer always take 2 pairs of socks with them? In case they get a hole in one. Okay, so example 5a, looking at the use substitution. So we see kind of a complex problem, x times root 2x minus 1. So kind of going with it right away. Maybe without thinking about it too much, you think, hey, we have an inside function. And then you go about doing that inside function, the use of presses. So u equals 2x minus 1, du equals 2 dx, then solve for dx, like always. So du over 2 equals dx. And then take their first and last piece, put them together. So x u to the 1/2 dx, du over 2. And you kind of see nothing magical happens, okay? So you know the old annoying thing, if at first you don't succeed, try and try again. So we're going to do that. We're going to do another u substitution. So take your original u equation, solve it for x. So u plus 1 over 2 equals x. And then the remaining x after your first u sub, plug that in. So we end up with definite integral u plus 1 over 2 u to the 1/2 du over 2. Both denominator 2's can pull out to be a 1/4. And then distribute the u to the 1/2 power into the u plus 1. So u to the 1/2 times u to the 1, u to the 3/2, u to the 1/2 times 1, u to the 1/2, du, and then do your integration, your reverse power rule. So 1/4. So u to the 3/2 becomes u to the 5/2, and divide by a new exponent, so 2/5, plus 2/3 u to the 3/2 du. So distribute the 1/4 in, resubstitute the u values. So 1/4 times 2/5, 2 over 20 or 1/10. So 1/10, 2x minus 1 to the 5/2 plus 1/4 times 2/3, 2/12, so 1/6. 2x minus 1 to the 3/2 and plus c. And I should not have done this du. Should have been the plus c back there. Alright. So a kind of a double u substitution. Do it once. There's still a leftover x. You could take your original u equation, solve that for x, do a second substitution, so you get rid of all the x's. Everything's in terms of u, du. Now the second part of this video is about definite integrals, okay? So let's go about this like we always do. So x squared plus 1, derivative of that's 2x, x outside of the parentheses is some form of the derivative. So we have our inside. So u equals x squared plus 1, and then implicit derivative, solve for dx, like we've gotten used to. Solve for dx, du over 2x equals dx. And put that together, so indefinite integral x u to the third du over 2x. Now this is the definite integral, right? Our bounds were 0 to 1 dx. And it's important, those 0 or 1, those bounds, what variable do they represent? Because this is dx, this 0 and 1 represent x values. Well now, down here, x cancel out. We have u and du. The 0 and 1, we now need u values. So right here, u equals x squared plus 1. Plug your x's in, we get u's. Plug in 0, you get 1. Plug in your upper around 1, you get 2. So now what we started with, everything was in terms of x. X bounds, x variable, dx. Now everything is in terms of u. U bounds, u variable, du. So now the denominator 2, pull that out in front. 1/2, definite integral, 1 to 2, of u to the third du. And you get 1/2, 1/4, u to the fourth, evaluated from 1 to 2. And now you have a choice. This problem can go one of two ways. You can stick with the u values. So 1/2 need to 1/4. 1/2, 1/4, u to the fourth, evaluated from 1 to 2. Or you can re-substitute your x values back in. So 1/4, now it's not u, it's x squared plus 1 to the fourth. And then re-substitute all of your x values, so the x variables and your x bounds. 0 to 1. So 1/2 1/4 1 squared plus 1. So plugging in the 1 upper bound minus plugging the 0 upper bound. So 1/4 0 squared plus 1 to the 4th. Close that off. And then you do some arithmetic, evaluate that. So 1/2, let's see here. 1 squared plus 1 is 2. 2 to the 4th is 2, 4, 8, 16. A fourth of 16 is 4. And over here, 0 squared plus 1 is 1. 1 to the 4th is 1, so 1/4. So 1/2 is mental math. 16 over 4 is 16 over 4. So 15 over 4. So 15/8. And let's see what we get if we do the other side. Okay, we use the u variable and the u bounds. So 1/2 1/4 times 2 to the 4th minus 1/4 times 1 to the 4th. We have 1/2. 2 to the 4th, again 2 to the 4th is 16, 4th of that is 4. And I think you can see where this is going. 4 minus 1/4 again is 15 over 4. And 15 over 8. So same answer both ways. So you can choose whether you want to go back to x values or stick with u values. Here's what's going to happen. They're going to grade you based upon your consistency. So right here, you need, right here, you need the new bounds because you have u, you have du. You need to change the x bounds to u bounds. You have to do that. Down here, you have a choice. You can stick with the u variable and bounds, or you can go back to the x variable and you gotta go back to the x bounds. Okay, either way you get the same answer, but consistency is in the name of the game. So take a look at the other examples, check my complete notes online.